Okay, so suppose we have a class that consists of 300 students. Each student attends the class with a probability of 0.6, or 60%. Assuming the students attend class independently, then on a given day, what is the approximate probability that at least 54% of the students attend the class? So when we're looking at a percentage or a proportion, what we want to know is what is the probability that the sample proportion p hat is bigger than or equal to 54%. Now, as you may have noticed, many of our formulas require that a proportion is in decimal form. So what we really want to do first is we want to rewrite this as the probability that the proportion of students who show up to class out of the 300 registered students is bigger than or equal to 0.54. Okay, so it is important to use the correct form when we're using our formulas, and the correct form for a percentage is always going to be a decimal. Okay, so how do we do this? We have a rule that says when n is large enough, then the proportion p hat is approximately follows a normal distribution, where the mean is p, or the probability that an individual student will attend class on any given day, with the standard deviation of the square root of p times 1 minus p over n. So for this problem, we have the proportion of students who show up to class on a given day is normal, and it has mean of 0.6, or 60%, and standard deviation the square root of 0.6 times 1 minus 0.6, which is 0.4, over the number of students in the class. So divided by 300. If we feel more comfortable simplifying the second number, what we get is the proportion of students who attend on any given day approximately follows a normal distribution with mean 0.6. And if I multiplied, divided, and then took a square root, I would get about a 0.028 for my standard deviation. Okay, so if I wanted to use my TI to find this probability, what I have, or what I want, is the probability that p hat is bigger than or equal to 0.54. And when we have a normal distribution, the way to find that probability on our calculator uses normal CDF. Now, normal CDF will always have four numbers. The first two is always going to be the low and the high. So the low number is 54%, or 0.54. So I'm saying I want to go from 54% to the biggest possible proportion is 100%. And 100% is a decimal, is a 1. Okay, and then my third number is the mean, which is 0.6. And the fourth number is the standard deviation. In this example, that's about a 0.028. So this is really only giving us an approximate probability, and also p hat is only approximately normal. So this is all approximate. If I wanted to solve for this, I would use my graphing calculator. I would go to second VARs as my distributions. The second option is normal CDF. So 0.54, comma 1, comma 0.6, comma 0.028 gives me an answer of about a 0.984.